Let me show you what I mean by this oscillation. If I put the bullet inside the coil and try to turn it on with my power supply here, well, it's always safer not to work with live loose wire, so instead I'm using these alligator clips here. I put the bullet in and turn the power supply on so you can see what's going on. There you go, you saw what happened. Oh. Now I like to use my 100 ohm resistor and connect it to the output to see how the waveform changes. And you can see a tiny negative sign beside it. That means that that side needs to be connected to ground or negative. Hi, how to make an electric guitar? Well, I don't know, but from the name of it, it's just a combination of guitar and electricity. Here's a simple one I made. Please join me for the first time to hear how it sounds. And 1, 2, 3, 4.
Alright, so I started by marking 3 dots in the project box around the driver. The marked dots were to have holes drilled through them for the 1/4" bolts. After the holes were drilled out, the 2.5mm plug was installed with some JB weld. The LED was left unglued because it was going to be pulled out later. I connected 2 prongs of the LED to some speaker wire and soldered them. Heat shrinks were placed around the soldered parts of the wire to identify the polarity. Once that was done, the driver was tightened down with 1/4" nuts and bolts. I trimmed the wires down so they could connect to the stat LED slot on the driver without having excess length. And it was at this moment where I realized that I improperly installed the jack. The prong sticking up was supposed to be facing right, not up. So I sat there for several hours picking at it with a toothpick, until the jack finally came out. Unfortunately, the jack fell apart from the removal, but luckily I had a spare jack to use as a replacement. JB Weld glue was used once again to install the jack. The same type of speaker wire was used to solder the 2 points on the jack to the switch A and B slots on the driver. The positive wire of the stat LED was soldered to the stat positive slot. The negative wire was soldered to the stat negative slot. I found these 4 steps of the project to be the most difficult out of all the others. Soldering points millimeters away from each other wasn't easy. The solder would often merge with the other points if they got too close to each other. But after many attempts, I was able to successfully solder the points. After the soldering, I started to work on the heatsink assembly. I took this computer fan and popped off the corner pieces to remove the plastic from the heatsink. Rubbing alcohol was used to clean the surface. I then set the heatsink aside and prepped the Cree LED for soldering. Speaker wire was soldered to the points of the Cree LED. Once that was done, I used a thermal adhesive to glue the Cree LED to the heatsink. I also glued the optics lens to the LED. While the glue was settling, I started to work on the LED cover. I took a 3/4" PVC plug and marked a line on the plug according to the height of the LED. A Dremel tool was used to cut through the marked line on the plug. Once the cut was made, I used an old plastic name tag holder as the cover of the PVC plug. I traced the circumference of the plug onto the plastic and cut it out with the Dremel. The cut plastic was then drilled to the top of the plug. Silicone sealant was used to fill the gap between the plastic and plug. I then started to work on the final solder points for the driver. The wires that were connected to the Cree LED were soldered to the LED positive and the LED negative slot on the driver. The Tamiya wires that connect to the battery were soldered to the IN positive and the IN negative slots. Finally, all the steps that required driver soldering were finished. I then used the same adhesive from before to glue the LED cover over the LED. I arranged all the components together. 2 3-inch bolts and nuts held the heatsink, bracket, and driver together. Weight was placed on top of the LED cover to keep it in place while the glue dried. After the glue dried, I attached the mount to the bracket. Washers were placed in between to keep the mount from sliding. The final step of this project was to make the remote for the light. I used perfboard for the base of the switch. I marked a 5x7 square with a marker and used the Dremel to cut out the square. I pushed the switch through the perfboard and soldered the 2.5 mono cable to the points. And voila! The remote was finished. The remote works well when connected to the light. I am able to channel through the different light settings. I went to a hobby store and purchased an airsoft pouch for the battery. The battery fits perfectly inside. Straps on the outside of the pouch are mountable to the front post of the bike. The project is finally finished. The total cost of my project was $231.30. I do not plan on selling this light. I plan on using this light for night rides.